Welcome to Astro Science Academy, and in this video I'll be showing you guys on how to answer questions based on Newton's laws of motion. Right, so let's have a look at this. So now over here we got question 5, which says block A initially at rest. So now initially at rest, this point over here indicates that V initial is equal to what? 0 meters per second, right? So it wasn't moving on a rough horizontal surface. That indicates that on this block over here, A, there'll be what? A frictional force, right? So over here, there'll be a frictional force. So now, they say now is connected to a block B by a light inextensible string that passes over a frictionless pulley. So over here, at this point, it's frictionless, meaning that there's no friction, right? So now the mass of block A is x kgs, meaning that it was not given. It's not given, it's just x kgs, right? While that of block B is 12 kgs. That means over here we know what the mass of block B, right? So that means we can be able to get what? Fg, right? We can be able to get Fg over here, right? And remember, block B cannot have a normal force because this block B is not on a surface on top of something, right? So if it, for example, if it was on top of the table, it would have had a normal force. So this block B is just hanging by itself, so it won't have a what? Normal force. So the only forces over here will be Fg and tension, right? So this T over here is the same T as that, right? So let's continue. So now when a force F of a magnitude of 125 Newton, right, acting parallel to the surface is applied as shown in the diagram below. Block A moves to the left, so now the direction of the motion, as we can see, is that side. So we're going to take all the forces that are going to the left to be what? Positive. Moves to the left at a constant velocity. So now the moment you see the word constant velocity over here, constant velocity, that tells you that acceleration, which is your A is automatically equal to what? 0 meters per second squared, right? So we see that, right? So now that tells you that Fnet is equal to what? 0. So now this obeys Newton's first law of motion, right? So now let's see that. So now over here, the first thing you always do when you're trying to answer Newton's laws of motion, you need free body diagram. It doesn't matter if the question asks you for a free body diagram or not. You need a free body diagram, because without a free body diagram, you won't be able to answer these questions. Right, so let's have a look. So now we know this is the direction of the motion. It's moving to the left. Now over here, we know we can get a force diagram here. Over here, we can get a what? A normal force. So now we know this is a what? Normal force. So I'll advise you to do the way what I'm doing it over here. You can do this on your question paper, right? And then down here, we can have Fg, right? Okay, let's do that properly, right? We can have over here, down here, we can have Fg, right, over here. And also we know friction is in this direction because friction always opposes the motion. So if the motion was to the left, friction will be into the right, right? Why? Because friction opposes the motion. It slows down the motion, right? So let's get a free body diagram for this. So now for block X, you can write here, you can say free body diagram for blocks X kgs. Now the first thing is the dot, always, right? And then you're going to indicate what? Fg, right? And then you're going to indicate what? Normal force, right? And then you're going to indicate what? Tension in the string, right? And then you're going to indicate your what? Frictional force. And remember to make your frictional force very, very small, right? Not too small, but a little bit less than other forces, right? And then you're going to make your force applied, right? So this is your force applied, right? Just like that. And then you can put a small slight arrow over here indicating this is the direction of the what? Motion. Now you're gonna draw a free body diagram. Free body diagram for what? The 12 kg block. Now over here there are only two forces that are acting over here, which is Fg, right? So you can have Fg over here, and the other force will be what? Tension in the string, right? Okay, let's do that properly over here. Tension in the string, right? So we got that. Now once you have all this information, now for this block 12 kg is moving, the motion is upward, right? So let's get that upwards, right? So you're gonna have your arrow over here upwards, and remember your free body diagram, please use a ruler so it can look neat. So now let's get the first question now, right? So now they're asking us state Newton's second law of motion. So guys, there's the Newton's second law of motion. I believe you guys know this. It says that when a net force x acts on an object, the object accelerates in the direction of the resultant force, or we can say what? Net force. We can say net force, right? Net force. This acceleration is directly proportional to the force and inversely proportional to the what? To the mass of an object, right? So now the formula over here comes down to Fnet is equal to ma, right? So the acceleration is directly proportional to the what? To the force. So as if the force increases, that means the acceleration also does what? Increases, right? Why? Because they're directly proportional. And then they say that also the acceleration, also this acceleration over here is inversely proportional to what? To the mass. So if the acceleration increases, the mass does what? Decreases. So if the mass decreases, acceleration increases. If the mass increases, the acceleration does what? Decreases, because they are inversely proportional, right? So we're gonna discuss this later on, right? So for now, let's answer this question. So now 5.2 says that if the coefficient of kinetic frictional force is mu k, right, between the block A and the surface is 0.25, calculate the tension T in the string. So now over here, as you can see, there's our formula over here, right? They gave us mu k, right? So now as you can see that Fk is equal to mu k times what? Normal force. So they gave us this. We need a normal force. So in this scenario, we know that normal force is equal to what? Fg, right? So Fg over here, Fg, we can't get Fg over here, as you can see, right? Because we need the mass, which we do not know. So it's just x times what? 9,8, right? So the other thing over here that we can get the normal force, that means we can't get the normal force, right? Also, let's have a look over here. Tension in the string. Do we have the tension? We don't have the tension. We have the force. We don't have friction. So it's two unknown. Now let's come over here on this free body diagram. We have Fg. That means we can be able to get what? Tension in the string. We can be able to get that, right? So I hope you guys saw how I analyzed the information over here, right? You always look where you have enough information. So let's work over here now. So now over here we know that Fnet, because remember it's moving under constant velocity, right? So Fnet is equal to 0. That's Newton's first law of motion. So now Fnet, the motion is going upwards, right? So now tension is going to be positive plus open bracket negative Fg is equal to 0. So now tension plus open bracket negative 12 times 9,8 close bracket, right, which will be equal to 0. So now tension will be minus, now you can pick your calculator quickly. You can put it on the side over here. You can put it on the side. Now you have negative 12 times 9,8, and that gives us 117,6. So now we have 117,6 is equal to 0. Now our tension is equal to 117,6 newtons. So that's our tension now, right? That means we can bring it here now. Now we have this tension. Now we can bring it over here. Now remember, when you're working with Fnet, you are going to consider our only horizontal forces, right? So now we know this direction, we take that to be what? Positive. So now you're going to say Fnet over here is equal to 0. So now Fnet, you're going to say F, because that's going to be positive, plus negative tension plus negative frictional force, close bracket, is equal to 0. So F is 125 minus tension, which we do know, which is 117,6, plus, which is going to be plus times minus becomes minus, FF is equal to what? 0, right? So now all you can do is transpose FF that side. Now you can sum this up. Now what do we get? You can shift this on the side. Now we have 125 minus 117, 6, and we get a final answer for friction, which is 7,4. So now frictional force is 7,4 newtons, just like that. And that is how we should have answered our questions. So now when you see something like this, remember, free body diagram, as you can see, is very, very important. Free body diagram, right? And you always look where you have enough information. That's the only thing. So as you can see, if you just went over here by looking at this formula, Fk is equal to mu k times n, only if you only looked at that, you would have been stuck, right? And you won't be able to maneuver this question, right? So now you have to look other ways on how to get the question. You need to learn how to think properly, right? So now let's have a look. So now 5.2.2, right? So now 5.2.2 says that the magnitude of the kinetic frictional force acting on block A, right? Okay. Oh, they wanted the tension. So I'll answer two questions over here. Okay, so this was 5.2.1, right? And then this is 5.2.2, right? Okay, you can keep it like that. Right, also they broke it down. Okay, that's good. Now they said, now calculate the mass of block A. They want to know the mass of block A, right? So now that will be 5.2.3. So now they want to know the mass of the block A, right? So mass of block A, as you can see, we got the normal force, which is equal to Fg, right? So now that will be the first thing that we're going to say. We're going to say the sum of all forces acting upwards will be equal to the sum of all forces acting downwards. In this scenario, there's only one force that's acting upward, which is the normal force, which will be equal to the sum of all forces acting downwards, which will be Fg. So now normal force will be equal to m times what? G. So now mass will be x times G, which will be 9,8. So that's our normal force, right? So now we're going to put this as in equation 1, right? So now let's come back to this formula over here, right? So now Fk is equal to mu k times n. So now we do have mu k, right? So now mu k is what? 0,25 times normal force, which we have, which says x times 9,8, right? This now is what? Fk. And what is Fk? We calculated over here, which is what? 7,4. So now we're gonna have 7,4, which will be equal. Now we can multiply that together. Now we can get 0,25 times 9,8, which will give us 2,45. 2,45x, right? Then you're going to divide here by 2,45, right? Divide by 2,45. Now that and that cancels out, and now your x will be, take your calculator. So now you have 7,4 divide by 2,45, and that will give us 3, hold up, Right, okay, let's take it back. So 3,02. So 3,02 kgs, right? That is mass, and this would have been our answer. So guys, please make sure whenever you're working with Newton's laws, the most important thing is free body diagram. Without your free body diagram, you won't be able to answer these questions. So that's it for today, guys. Thank you for attending, and I'll see you guys next time. Take care.